Hello guys, welcome to Apex Math. My name is Bino. In this video, we go through question 5 from the August 2025 N4 Mathematics question paper. Question 5.1.1, we sketch the graph of y is equals to e to the power x and y is equals to e to the power negative x and x is equals to 2, and we also have to show the representative strip as well as the area to be calculated. We are sketching three functions: x is equals to 2, y is equal e to the power negative x, and y is equal e to the power x. Let's start by plotting the x is equal to. So we draw the graph x is equals to 2, and we draw the graph y is equals to e to the power x. When x is equal negative 2, y is equal 0,135, which will be somewhere there. When it's equal negative 1, it's equal 0,3679, which will be somewhere there. When it's equal 0, then y will be equal 1. Let's have 0,5 somewhere around there. When x is equal 0,5, y is equal 1,648, which will be there. When x is equal 1, y will be equal 2,71, which will be somewhere there. And when it's equal to 2, y will be 7,389, somewhere up there. So let's join our points, and we have this as the graph of y is equal e to the power x. Let's draw the graph y is equal e to the power negative x. When x is equal negative 2, y will be equal 7,3891, which will be somewhere up there. And when x is equal negative 1, y will be equal 2,71, which will be somewhere there. And let's have negative 0,5. When x is equal negative 0,5, y will be equal 1,648. And when it's equal to 1, y will be 0. When x is equal to 0,5, our y will be equal 0,606. And when x is equal to, y will be equal 0,1353. So let's join our points. I forgot the point x is equal 1, so don't be tempted to shade this area. So this area doesn't have any boundary, especially when it goes to negative infinity. When it goes to negative infinity, it doesn't have any boundaries. So instead, we shade this portion. Now that we have our area, we draw the strip, and the strip has to touch both graphs inside the area in question. So only when it's vertical will it be able to touch the two graphs. Since our strip is vertical and it touches the x-axis, we name it dx. So whatever we'll be integrating will integrate with respect to x. So our strip is named dx. Question 5.1.2, we calculate the area indicated between two functions by means of integration. The formula to calculate the area using integration is available in the formula sheet, as area is equal the integral from point A up until point B of y2 minus y1 dx. This will be equal the integral of y2 minus y1. y2 will be the function which is at the top on our area. Where our area is, the function which is at the top will be our y2. The y is equal to e to the power x, and the y is equal to e to the power negative x will be our y1. So we minus the one which is at the top with the one which is at the bottom. So we have e to the power x minus e to the power minus x dx from A to B. So where does our area start? It starts when x is equal to 0 and it ends when x is equal to 2. So our A will be 0 since our area starts from 0, and our B will be 2 since our area ends at 2. So now we integrate. So our area will be equal, the integral of e to the power x will be just e to the power x minus the integral of e to the power minus x, which is just e to the power minus x. Since we are integrating, we divide by the derivative of that negative x in the exponent of the e. The derivative of e to the power negative x is negative 1. So we divide by negative 1. We have our boundaries from 0 to 2. Let's simplify. We have a is equal e to the power x, and that negative divided by that negative will be positive e raised to the power negative x, and our boundaries, we have the 2 and the 0. We start by substituting the bigger number first. So our area will be equal, where there is x, we are going to substitute the 2. So even here, we substitute the 2 where there is x. We minus this by, now we substitute the 0. So we'll have e raised to the power 0 in the place of the x, plus e raised to the power negative 0. And our a will be equal, so the e to the power 2 plus e raised to the power negative 2 is equal 7,524 minus the e to the power 0 plus e to the power negative 0 is equal 2. Any number to the power 0 is equal to 1. So 1 plus 1 is 2. Our area will be equal 7,524 minus 2, which will be equal 5,524. Since area is measured in millimeter square, centimeter square, or meter square, and we are not given any SI units, so we use unit square. Question 5.2, we evaluate the following definite integral, and to evaluate this, we are going to use the formula sheet, and the formula that we are going to use will be that one which is highlighted, but we don't have a constant before the 5 to the power 2x, so let's cancel the k. So our integral in this case will be equal the 5 to the power 2x as it is. So the 5 to the power 2x as it is, we divide this by the ln of the base. So we have the ln of the base, and our base is equal 5. But we have to divide this by the derivative of the exponent according to the chain rule. So the derivative of the 2x is equal 2. So we divide. If we were differentiating, we are going to multiply. We are integrating, we divide, and we have our bounds from 0 to 2. Let's rewrite as 5 to the power 2x, and we instead write the 2 first. So we have 2 multiplied by the ln of 5 with our boundaries, the 0 and the 2. Let's substitute. So we start by substituting the bigger number, the 2. So we'll have 5 raised to the power 2 multiplied by 2, 2 in the place of the x, and this will be divided by 2 multiplied by the ln of 5 minus, now we substitute the 0, so we'll have 5 raised to the power 2 into the 0 in the place of the x divided by 2 multiplied by ln of 5, and this will be equal 193,856, and this will be our answer for this question. Question 5.3, we have the following indefinite integral. To simplify, The first step here is for us to realize that we have a difference of two squares. So let's rewrite our integral as equal. So we rearrange that 25, we write it as 5 squared, and we have the sec squared of alpha minus, so that 4 we rewrite it as 2 squared divided by 5 sec alpha minus 2 the alpha, and we can further rewrite this as the integral into 5 multiplied by sec alpha all squared minus 2 squared, and this is divided by the 5 multiplied by sec alpha minus 2 the alpha. So suppose that we had a squared minus b squared. This difference of two squares will factorize to a minus b multiplied by a plus b. So we also have a difference of two squares in the numerator, which it will simplify and factorize to into 5 multiplied by sec alpha minus 2 multiplied by 5 sec alpha plus 2 divided by the 5 sec alpha minus 2. Okay, I forgot the d alpha there, so we have the d alpha. Even here, let's have the d alpha. This 5 sec alpha minus 2 will cancel out each other, and this will be equal the integral of 5 multiplied by sec alpha plus 2 d alpha. We use our formula sheet to determine the integral of sec alpha. On our formula sheet, we are going to use that formula. So the integral will be equal 5, which is just a constant, and the integral of sec alpha will be equal the ln of sec alpha plus tan alpha. The integral of the 2 with respect to alpha will be equal to alpha plus our constant c, and this will be our answer for this question. Question 5.4, we integrate the following with respect to x. So let's simplify first before we can integrate. We start by simplifying. Remember that 1 divided by sine x is equal cosec x. So this will be equal cosec x. When we cross multiply, remember that the cosec x is divided by 1. We cross multiply, we get 1 is equal to cosec x multiplied by sine x, dividing both sides by cosec x. Sine x will be equal 1 divided by cosec x. So in our case, we have 1 over cosec 3x. So this will be equal, the integral of the 3 multiplied by sine 3x in the place of 1 over cosec 3x. We only need to simplify that one term. So I'm just going to fast forward for the rest of the terms. Alright, so now we can integrate. This will be equal 3 multiplied by the integral of sin 3x, which will be equal to negative cos 3x. Remember, when we differentiate, we multiply by the derivative of that 3x. Now we integrate. The derivative of the 3x is 3. We divide. Minus the 7, which is just a constant, multiplied by the integral of 2 to the power 3x, which will be just 2 to the power 3x. We divide by the ln of the base. Remember, this is on the formula sheet. The derivative of that 3x is 3. Instead of multiplying, we divide by the 3, the derivative of that 3x. Plus the 2 pi, which is just a constant. And the integral of e to the power 2 to the power x will be e to the power 2x divided by the ln of the base, the ln e. So you don't have to write the ln e because ln e is equal 1. So the ln e is equal 1, but the derivative of that 2x is 2. So we divide by 2 instead of multiplying since we are integrating, plus the integral of the 10 to the power negative 2x will be the 10 to the power negative 2x divided by the ln of the base. The base in this case is that 10, so we have the ln of 10 multiplied by the derivative of the exponent. The derivative of the negative 2x is equal to negative 2, so we divide by the negative 2. The integral of the 3 pi divided by 6p will just be the 3 pi multiplied by x divided by the 6p. We use the formula sheet to evaluate the integral of cosec x cot x. Remember that integration is the reverse of the derivative. So we have that shaded formula. So the reverse will give us the original function y, the reverse of that derivative. So the integral of cosec cot x will be negative. The reverse of that will be negative cosec x plus our constant c, which I don't have enough space for. I have absolute confidence that you guys will be able to simplify this, and after you simplify, this should be your final answer. Thank you guys for watching. If you have any questions, you can drop them in the comment section below. Remember to subscribe, like, and share the channel if you find this content useful.